I'm going to show you how to draw a Lewis diagram using two examples. Suppose you had to find the Lewis diagram for the molecule NH2Cl. To do that, the first thing I'm going to use is a periodic table, because this periodic table actually shows me the number of valence electrons in each of those atoms. I can do that by looking at the group numbers along the top. I can see that nitrogen is in group 15, so it supplies 5 valence electrons. I take the last digit. I can see that chlorine is over in group 17, so that means I take the last digit again, so chlorine will supply 7 valence electrons. Even though hydrogen is usually shown in the middle there, it's actually considered a part of group 1, which means that each hydrogen will supply just 1 valence electron. I'm going to keep a note of these numbers after I total them up, so that gives me a total of 14 valence electrons to work with. Step number 2 is to actually start choosing a central atom. Now, the first thing about choosing a central atom is that it's never ever going to be hydrogen, so don't put hydrogen in the middle. This means I'm left with the choice of either choosing the nitrogen or the chlorine. If you're left with the choice, you're going to pick the element which is the least electronegative. So we're going to choose nitrogen as our central atom and pop that down, and we're going to put the other elements around it. The third thing we're going to do is to create single bonds from the central atom to the outer atom. Each single bond is represented by a line. Each single bond represented by this line also represents 2 electrons. So out of the 14 electrons we had, we're going to pull out 2 electrons at a time to create single bonds. When we do that, you can see that I made 3 single bonds, so I use 6 electrons. That brings me down to 8. The next thing I'm going to do is that I'm just going to do a quick count of the number of electrons on each atom right now. I can see that chlorine has 2 electrons. I can see that each of the hydrogens have 2 electrons. And I can see that the nitrogen, because it's got 3 bonds around it, has 6 electrons. The reason I do that is because in this next step, I'm actually going to start placing the remaining 8 electrons somewhere. To do that, I need to place the electrons on the outer elements first, and then the central atom. I also need to follow the octet rule, which means that every atom should have 8 electrons. The exception to that is hydrogen. So hydrogen has 2 at the moment out of 2, so that's actually okay. So I'm going to start with the chlorine, which means that this chlorine has 2, it needs 6 more. So let's pop in another 6 onto the chlorine, and I'm now suddenly left with 2 electrons. These remaining electrons go on the central atom. These remaining electrons are what gives us our lone pair on the central nitrogen atom. In example number 2, I'm going to show you the Lewis diagram for a molecule such as carbon dioxide. I do the exact same thing as I did in example 1. So I'm going to need my periodic table again, and I'm going to look for the carbon and the oxygen on the periodic table. Carbon's in group 14, so carbon supplies 4. Oxygen's in group 16, so that supplies 6. Remember, when I'm taking the last digit, this gives me a total of 16 valence electrons. After that, I'm going to choose a central atom. My choice is between the carbon and the oxygen, and carbon is the least electronegative one, so we're going to put carbon in the middle, and we're going to put the 2 oxygens around it. After that, I need to start creating single bonds from the central atom to the outer atom. Remember, I show this by using a single line, which represents 2 electrons, which represents 2 electrons being shared, which means that I need to use 2 electrons at a time. So when I do that, you can see that I'm creating 2 single bonds. I just used 4 out of my 16, so I've got 12 left. After that, I'm just going to do a quick count of the electrons. Each oxygen has 2. The central carbon has 4 because it's got 2 single bonds around it, and each of those bonds represents 2 electrons. Now, again, just like before, I need to place the remaining electrons on the outer atoms and then the central atom using the octet rule. So oxygen's got 2 out of 8, carbon's got 4 out of 8. So with my 12 remaining, we're going to place them on the outer atom. So there's oxygen and there's the other oxygen done. This means that I've got no more electrons left, but we've got a problem now because carbon only has 4, but it still needs 4. This is when you create multiple bonds. To do that, you need to look at the outer atoms and start using pairs of electrons, so 2 electrons at a time, to create new bonds towards the central atom. When I do that and I do my quick recount, each oxygen actually still has 8 out of 8, but when I recount on my carbon, I can see that it now has 8 out of 8 as well. Choose phosphorus. I'm going to plonk that down into the center. My dog just sneezed. Remember, everything's going to follow the octet rule except for hydrogen, which means that when I look at chlorine, and I'm going to start with the outer atoms before the central atom, but when I look at chlorine, there's only two. It needs this isn't going to work, hey Toast?